Can start. So, hello everyone, and welcome to Makers Demo Day. I'm Anastasia, and I'm the Client Partner Administrator here at Makers. And today, I'm sure we have some really fun and interesting presentations and final projects that some of the devs will be sharing with us today. So, as you know, we are makers, and our mission is to transform lives and organizations by bridging the gap between tech industry needs and underdiscovered talent. So, a little bit more about our makers. They are a dedicated and passionate group of individuals who are ready to make an impact in the tech industry. They've worked extremely hard to develop both their technical and collaborative skills, showcasing their consistent growth and determination. In terms of skills and growth, they've gained the essential skills and a solid technical foundation, learning programming languages and problem solving techniques and things like that, which is wonderful. And our bootcamp journey is typically around 16 weeks, but the first half is kind of focused on building a strong foundation, and the second half is where they dive into their chosen specialism and apply their knowledge to kind of real world projects, which we'll be seeing a little bit more of in today's presentations. Through collaboration and innovation, they work as a team to develop not only technical skills, but also their ability to collaborate and communicate effectively. And today's showcase is just basically after months of hard work, our makers are excited to present their projects, which will demonstrate the growth, creativity, and the impressive skills that they've developed during their time at bootcamp. So a little bit of housekeeping. We ask that you please stay muted for the duration of today's presentations. Each presentation should last around 10 minutes. And after each team goes, you'll be able to ask any questions if you have any, and they'll be able to answer them. And so now we're going to hear a bit more from our tech coach, Kerry.
Hello, thank you so much. Welcome everyone. Thank you for coming along. So today we've got our cloud cohort doing their presentations. Been working hard over the last 8 weeks on all things cloud. So I'm just going to give a little bit of background about the cloud course in general, and then I'm going to give a little bit of an introduction to the project they've been working on, because it's a bit different to what they do in software development. You're probably more familiar with what software engineers do, which is kind of work to design and build systems, and like write the code. And cloud and DevOps engineers' jobs is kind of everything after the fact of pull requests. So deployments, making sure systems stay available, reliability, how to use cloud providers for this. They use AWS in this course. And on top of that, a massive part of it is communication and planning, everything. So they've had a super intense week of learning so many new skills. There are at least 12 different AWS services that they've used, which is mad. Lots of things to learn, and absolutely taking it in their strides. So this final project has been all about reliability. So we've got two teams presenting today. They both had the same project, which is a completely real scenario that has been set up. So there's a group of vet hospitals that they hired a company called Hosp to build them a system for all their veterinary hospital needs. But it's a bit clunky, doesn't work that well, a bit unreliable. So our students have been brought in as crack teams of cloud engineers to come and make things better, with a few caveats of HOSP knowing exactly what's going on. We're being brought in to take over. So they're very uncooperative and don't want to help our devs. And to that end means that our engineers didn't have any access to source code. They only had access to a load balancer. So lots to try and work out as to what to do and where to even go, and very little information. So with that, I'm going to hand over to our first team, which is Team Water. Unfortunately, we've got a few people off sick in this team today. Not ideal. So I'm going to pass over to the lovely Teo and Toby, who are going to power through with just the two of them.
Hello everyone, I'm Taya and I'll be trying to represent team, we're called Team Water. Uh, can you see my screen? Hello?
Yes.
See my screen fine?
Yeah, we can see it.
Right. So as Gary said, we had little to go with, and then the logic was to not try and dig a hole, but we kept on digging hole, a hole, a hole. Um, because that's what we tried. But first things first, the mission was to protect the city, which was the application, the web server, and the idea was to keep it reliable and to prevent bad actors from actually coming in and causing chaos. Um, to do this, we had an idea. We started out with phase one, and the phase one was to actually just um, try and get an understanding of what the problem was. So to do that, we called on AWS S3 buckets and Athena to actually run queries. But prior to that, we had other documentations like API documentations we had to go through. And that kind of led the step into, okay, we needed to have have a space where we could actually collect the logs and then go through the logs. But when we went through the logs, some of the issues that we identified was like we had 49 and 500 errors. I won't go deeply into that, but it pretty much means misconfigured IPs or IPs not taking, um, giving them the desired web page or request that they made. And the first thing we decided to do as a team was to actually um, deploy an Nginx proxy, sort of like a reverse proxy technology going on there. And the idea was to pretty much take copies of the web server and actually put them on various EC2 or instances to actually guard the city so that requests that are coming in can actually come in and out. Not very one door, but actually with with help from other instances coming in to help or shielding or protecting. However, we did that, but we kept on having issues. It did not work. So we actually set up EC2's beginning. It was fine. It was okay. We put on the security protocols. We did everything we thought we were supposed to be doing. However, we got into a place whereby our EC2s were failing. They were unhealthy, and well, these guys started coming in. We started getting bad reports, so we actually had to put them down and do like a lockdown shutdown. We then went into a different phase, which is we tried to use a different kind of tool called Lambda to actually shield the network, shield the, 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 the web server. However, um, the special power for this was that we have the ability to instantly scale. We would not have to manage anything ourselves, but we did not manage to do this. We tried, it did not work out properly. Problems happened, and this tool didn't work for us. But to give you a better understanding, some of the issues we started having were like we tried different things, but we have things like Loki's illusion, like Avengers, whereby we had misconfigured proxy pass rules and EC2s were falling down. They became very unhealthy along the line and they couldn't stand to defend. Well, we lost those men. They kept failing their health checks and lambdas were timing out. And pretty much we got to a point whereby we had to actually shut down all unhealthy EC2s instances and start from there. So we then decided to pivot and focus on just the load balancer, which is mainly the only tool we had. The logic there was to actually replicate this, but we tried to manually replicate this. This is where the did not work as well. Then we tried to do something else called proxy pass rules, where that would actually help us create various illusions of the main server. That did not work as well. But we decided that we were going to focus solely on the load balance, and the idea was to actually increase target groups. We managed to do that, but that did not work as well. So um, because of that, we that did not work as well. So we then paused and said we were going to not try and do anything. And the last result we did, because we were still getting errors popping in from our logs. So we then decided to auto scale the healthy load balancer that we had. We auto scaled it and we asked it to actually try and keep we asked the auto scaler to actually ensure that the servers were up and nothing went down. So we managed to do that, and that's where we're at the moment. So at the moment, we've lost some men along the line, but we're still up and standing. And the idea now is, while the auto scaler is is letting us stand at the moment, we'll actually have to go focus on each bigger issues and try and conquer from that angle. But we made some other configurations along the line that actually helped us. So, for example, we had X3 buckets to store new images. So we have some data that we can actually use. We created templates, which created template of the first load balancer. So if it crashes, at least we have an image or a template that we can actually use to actually raise the city back up. So those are some of the things we've done for now that we're holding on to. But we did some other things, and did not most of them did not work out. But the learnings we've taken from this as a team is we needed a better way of working. So we went in without a foolproof plan, and the idea is that moving forward, we should probably have a plan that we all agree to, because what we had was we had different soldiers or different Avengers that had ideas, and we were actually just doing them all at the same time. So we can't even tell you what worked or what did not work, because we don't even have documentations to tell us or to allow us to what's working or what's not working, because we at some point we're implementing all these things at the same time. um, but moving forward is to communicate, have a clear plan as a team, and actually try one thing and allow it and see where it leads us. If it fails, then we pause, but not to do everything at the same time. So that's the plan moving forward to keep standing. Thank you. Any questions?
Thank you so much, Teo. Yeah, just massive appreciation to Teo, who we knew that she was likely going to be the only one presenting today, and she wanted to do it anyway, and came and gave the presentation all on her own, representing the team. So, like, super great work, and thank you so much for doing that. A lot of hard work went into that. So yeah, well done. Um, should be super proud. Does anyone have any questions? Oh, okay. We've got a question from Paul. Some great learnings in there. Well done. What was the bit you found most interesting from the project?
Least interesting.
Most interesting.
Most interesting. That we actually all have different ideas, and there's actually more than one way to actually resolve the issue, but we actually just never focused on one to actually see it through to the end. But it was interesting that we had more than one way to actually try and keep the team or the website standing. So that's the learning we're taking from, or the most interesting thing.
Thank you so much. And yeah, lots of people say they love the Marvel analogies. I love those two. So good.
So,
So
guys,
inventive.
I tried actually. Some of the team members actually gave me that, but I'm not sure I could give it enough justice. But it's there
I
for
think you
you.
did great. I think you did great. Okay, awesome. Thank you so much. Okay, I think I'm gonna pass over to the other team now. I don't think there's more introduction I need to do. So, Team Air, it's over to you guys.
All right. Does it look good? Everything look good? Yeah. Okay. Cool. So, hello everybody. Thank you for joining our demo day here at Makers. Today we'll be presenting our final 2-week project that rounded off our cloud/DevOps specialism course. So for the past couple weeks, we've been working together as Team Air, consisting of Emily, Etienne, Calvin, and myself, Alistair. At the start of the project, we were presented with a scenario that Carrie has sort of briefed us on, but basically the scenario would test our understanding of everything that we had learned so far, and to push us to learn new concepts in AWS services that we hadn't touched before. So the premise of the scenario is as follows. Our team is part of an organization that provides software and services to veterinary hospitals. The system that the veterinary hospitals use and we provide and maintain is called HOSP, and it's entirely hosted on AWS. At the start of the project, the system was not reliable. Sometimes it was slow, sometimes it was just offline. And it was composed of a few components, most of which were out of our control, but the part that we did control is the cloud infrastructure and middleware between the hospital staff, who are our users, and the HOSP web server, which hosts the web application being used. So our job was to monitor, maintain, and improve the system by managing existing resources, to provision more resources as we saw fit, and to handle any problems that would be thrown at us over the 2 weeks.
Yeah, so this was the initial architecture of what we were working with. There were 3 main components. That little bit there in green, that is the only section that we had control over. We had users, the vet hospitals, definitely a real thing and not a traffic generator, that were getting responses. They were coming in and going to the web server, but we were, as Alistair said, essentially the middlemen. We were managing traffic going into the web server. Essentially, we could only work in this area to add to the infrastructure, making sure the whole while we were maintaining the functionality of the system and then trying to improve the reliability and its use. So some of our project goals and improvements, our 2 main ones, were that the system should respond to 99% of user requests, and there should be no security breaches, which they tried and they succeeded, but we did our best. And then some extra kind of would be nice to have improvements that we got round to in the end. So the first thing we did was set up S3 buckets and logging. Essentially, we wanted to gain a lot more visibility on the requests that were coming in. We wanted to see where they were going, what response they were getting from the web server, and using that information, querying with Athena, which was a new tool to us at the time, we could start to see where the error messages were starting to pop up. And then, as you can see, this is the infrastructure as it starts to grow. You're going to see this get a lot bigger over the presentation, but this is just the first little iteration of our S3 bucket that is holding all of our logs.
So once our logs were set up, we noticed a lot of strange traffic coming through, and we did a bit of research and found AWS WAF, which is a web application firewall service, also known as WAF, that helps protect web applications and APIs from common web exploits. And as we had noticed suspicious traffic coming into our system, we thought this was a good place to start. We set up a firewall to block traffic that didn't match the search string intended for this project, but little did we know, we accidentally set it up to block all the traffic to the web server. So after some initial panic, as failures climbed, we took down the firewall, we made some changes to the statement, and once we set it back up and running, things went much smoother and the failures stopped, and successes began to climb back up again. The firewall sits in front of the load balancer, so all the traffic needs to go through it in order to hit the load balancer and continue through the system. With this, we use CloudWatch to log everything that was happening within the firewall, which made everything much more visible. Later, though, with our logging, we discovered that we were getting a lot of 500 errors and seemingly random endpoints on the API documentation. This meant that there was an internal server error, and it said to please try again, which is why we decided to set up a Lambda function to enable retries on all the failed requests. Lambda functions are written in Python, which was nice, and allowed us to capture the method, path, headers, and body, and use a for loop to try and pass the HTTP request to the host server again. If it returned an error code, it would retry the request using an exponential backoff algorithm, and if all the retries, up to a limit of 3, failed, it would then respond with the error code of 500 again. And as you can see in the graph, before the Lambda was implemented, we were getting quite a few errors, but afterwards they significantly dropped and our success rate went up significantly. Here you can see the retries Lambda function sitting between the load balancer and the host server. To implement this, we executed a staged rollout of our Lambda function and diverted first 10% of all traffic through it, then monitored successes and failures, then we upped it to 20%, followed by 50%, and then lastly started sending 100% of our traffic through the retry Lambda function using the target group listener rules. Like the firewall, we used CloudWatch to log what was happening in the Lambda function, and this helped us fine-tune the Lambda script.
Great. So now the fun started. There were a couple of hackers, we shall not name them. On Wednesday or Thursday, we received a message that a record for a patient had been changed with a delightful note that I now can't remember. But yeah, we'll leave that because it was very polite. Springing into action, we decided to have a look at all the ALB logs that we were putting into Athena. A few queries later, we saw a specific IP hammering a specific endpoint. The endpoint ended up being starts me, which we understood was essentially like a login form or something like that. It looked like from the logs, they were either phishing or stuffing credentials to see what stuck. The logs also told us that the user agent was Ruby, which normally means it's some kind of automated script, which would kind of ring true for the situation. The screenshot that's on the screen at the moment is just a quick excerpt of those of the actions that actually took place when they did change the record. So you can see here an IP in particular. Did we hide it? Yes, we did. Thank goodness. Okay, panic over. There is this particular IP is found and used through the SQL query. So this particular IP is hammering the staff's meet endpoint with GET requests, which are receiving 401s, which generally means unauthorized. This is normally a good indication, if there's many of them over a short period of time, that someone is up to something that you don't really want them to be doing. Shortly after that, there is a 200 response, which means it's a success, and that's on a GET, which should definitely be worrying. If you ever see this, it's worrying, because this generally signifies that they've successfully done what they were looking for. In this case, it was staff member number 4, Marshall. Sorry, bud. At this point, we probably should have also recommended some good password practices, but we didn't, so we'll skip past that and pretend it never happened. Following on from that 200, there are a couple of failed posts. Not entirely sure why they failed, but shortly after that, there's a successful one with a 201. So 201, just like the 200, is a success, but the one at the end signifies that something new has been added. In this case, it was a note. After investigating this properly, we confirmed that the time frame and the logs that you can see at the moment were down to the various hacker, which we won't name because that would be terrible. So we decided to do something about it. Yeah, these are the hackers, but we've no idea who they are. But yes, so we decided to do something about it. We started looking at rate limiting. There's a couple of things that we could have done, but we first started with rate limiting. What does rate limiting do? So rate limiting is a great tool which helps you protect against help and protect against things like script kiddie, bad actors, web scraping, service degradation. It helps to keep things stable, basically. Initially, we added a blanket rule, which in hindsight, and we soon found out, was not a great idea because we set it a little bit too strict. I think it was 20 requests in a minute over the entire domain, which wasn't smart. We found out very quickly that this didn't work, so we went ahead and did a bit of a more granular, what's the word? Can't think of the word. Setup. Let's use setup. a bit of a more granular setup where we put a rate limit rule on every single endpoint we had, which allowed us to adjust it as we saw fit. I think we went something very standard, like 300 requests for 5 minutes, but not important. That then led us on to the next thing that we were going to add on, which was an HTTPS redirect. So for clarity, all of the web traffic, all of the traffic that was coming in is and was HTTP all the way to the back end. So this made it quite easy for whoever those mysterious hackers were to manipulate or adjust some of the traffic or requests that were coming through. HTTPS in general speaking, as a layer of encryption all the way through from the infrastructure, from the back, from the start all the way to the back. How to explain it? Yeah, it adds a layer of encryption, which is just basic security. So this, yeah, no, we'll move on because I forgot what I wanted to say. How did we add it? Well, we started altering the load balancer that we had. Initially, we requested a new SSL certificate, which we won't say we weren't supposed to do, but we did anyway. So we requested an SSL certificate. We adjusted the HTTP 80 listener to redirect any traffic that came on port 80 onto a new listener, which was 443, which is just the port for HTTPS. And we also added one particular rule, which isn't shown there, but we added one extra rule because we noticed when we started redirecting everything to HTTPS that one particular endpoint was failing, so we just added a bypass. So this, along with the WAF rules that were added for rate limiting and for the valid URLs, gave us a nice respite from the pesky hackers. Thanks, John and Kerry. Sorry. We then moved HTTPS somewhere else.
So the last bit of infrastructure that we provisioned, we used it to optimize content delivery by using caching. This was because at the beginning of this week, we were warned that our hospitals were preparing to take in a huge amount of new patients as a result of a batch of tainted dog food that had been distributed at a nearby event. We knew that this would mean that there would be a huge influx of traffic coming into our system. So we had to quickly think of a way to handle this looming problem. And what we decided to do was to set up CloudFront to sit at the front of our infrastructure, primarily to handle our caching behavior, which in turn would take pressure off of the load balancer and the host web server itself.
Yep, so this diagram is just now the updated and probably most up-to-date diagram we have our infrastructure. We've added CloudFront in there. This will take all of the requests that are sent towards the system. It passes it through, goes through the rules, and then passes it back to the web server. So what does CloudFront actually do? Well, we use CloudFront for caching, which I'm pretty sure I just said, so I apologize. Yep, we're using it for caching. What does this mean? Essentially, if you go to your favorite website or the favorite location on your favorite website, you're not always reaching the backend because you don't need to if they have a CDN in place, which is Content Delivery Network. That's what we're using this as. It means that content is served back to you quicker. There's less load on the back end, and this helps alongside a bunch of other things, can help to do with help to build reliability. The main change we needed for this was to alter some of the Route 53 records, one in particular. All we did was change from, we made a change from instead of when you go to the URL for the animal vet hospital stuff, instead of it going to the access, the ALB, it would hit CloudFront first. So we just change a quick DNS record to point to the CloudFront. Then we checked this was working with a couple of commands, just curling to make sure that we could actually get through the CloudFront, get through load balancer, get the data that we wanted, but then also with NSLOOKUP, because that showed us the DNS records for the domain, which had then changed to CloudFront, which was great. A side note to this is we as with all the other servers we were using, we were exporting the CrowdFront logs to S3 so we could query them with Athena for anything that was just not working. And finally, the only thing that I haven't mentioned, as the HTTPS redirect used to sit on the load balancer, we moved it to CloudFront. This was mainly so as more respective of kind of what a real world system would look like, but also any load that was being used for the redirect, which in a normal world should be pretty small, but that was moved away from the load balancer to also help reliability and moved onto CloudFront, which can natively just handle it with a couple of behaviors. Yeah.
So I think you can tell by our dashboard we had a rather chaotic 2 weeks. We had some very high highs and some pretty low lows. And I think some of our takeaways for this, one of the biggest was stop the bleeding, then start the fixing. So I think what happened a lot of the time is we would kind of rush headfirst into slapping on new infrastructure. We tried to do as much research as we could, but a lot of the times, as you can see with all those red lines, they ended up not working and harming the functionality of the system. So we tried to maintain an idea of if it's breaking the system, if the vets can't access their data, let's take it down, let's fix it, and then we'll put it back up. Because I think this idea of testing AWS systems and services before we implement them, that was quite new to us. We weren't quite used to how we should approach in a real world situation improving a system without harming the reliability. So that was a big learning curve for us. We eventually got there, even really early in the project, learning with the Lambda and having it growing exponentially in traffic that we were feeding it to get to 100%. We were slowly learning as we went along to not just stick everything at 100%, and that is where most of our bad days came from. As always, logs are just a perfect way to view what's going wrong and investigating the good things, the bad things, everything that's happening within your system. And I think we were really on top of logging really for everything. We logged the WAF, we logged the Lambda, we logged the CloudFront. We had a lot of coverage and we had a lot of things to check. So we were always able to kind of get at least a rough idea of what was going wrong. In that same vein, error codes tell us when something's going wrong. We didn't always understand why, but we could at least start to move forward knowing where the problem was coming from and what exactly it might be related to. And I think another big learning point was for us in these 2 weeks. I mean, we've covered a lot of AWS services in the last 7 weeks, 8 weeks. But even in this project, we were learning new ones like WAF, CloudFront, and kind of learning as we were going along was a really interesting experience and I think quite challenging. But I think we all rose to the expectations and managed to make a decent project.
The final thing is, if we were to do this project again, there'd be a few things we'd keep in mind. Would be to utilize all the new systems of AWS that we've learned in this project to better be able to anticipate what potential problems there may be. But of course, this would be easier to do with more familiarity of AWS and cloud infrastructure. Another thing we would use next time are more alerts. In this project, we used the dashboard, the one on the right-hand side of the screen, to monitor any fluctuations and failures and successes, which meant you needed to have eyes on it if you wanted to see changes, and then you'd have to wait for the logs to start coming in, and alerts would help a lot from a monitoring standpoint. And finally, we would definitely look into built-in ways to test a new piece of infrastructure before deploying it, as most of the AWS features we learned after a bit of panic that there was almost always a way to test it out first. So yeah, a lot of things we would definitely take forward into future projects. And yeah, thank you guys so much for coming to our presentation today.
Amazing. Thank you so much. Let's skip the part where you accidentally had too much access to AWS. Amazing job, team. So many things. This team they've used the most amount of AWS services I've ever seen used in a final project, which super impressive. And yeah, asking me all sorts of things. It was wild. You did such a great job. So super well done. I hope you're really proud of yourselves. And yeah, I don't know who those hackers are. I don't really recognize them, but maybe we should put out like a search or something because it seems pretty bad, right? Shouldn't have hackers on the loose. Uh, but we have some questions. So we got one from Paul. Nice work, team. How did you identify that there were hackers altering the data in the first place?
So I think what we did was, first of all, just noticing that there was a lot of traffic coming in from an IP address that we hadn't seen before. That was sort of the first signal that told us that something was happening. Luckily, we were told that we had been hacked, but really just digging down into the logs, trying to find the exact requests that were coming in, and trying to notice any sort of patterns in the logs, to get some insight into exactly what they were doing and what they were changing.
I also got a very upset Marcus on the phone from Marcus. Is that whose account was hacked? Marshall, a very upset Marshall on the phone, saying, "I don't have access to my account. Your engineers have ruined something." So they got that message too. We've got a question from Marcus. Very well done. Do you feel more equipped now to take on a similar game day challenge than when you started and avoid Black Wednesday?
I think I think we do feel a bit more confident. I think you would need some sort of senior engineer to be overseeing a proper game day, but if there was one that was at a similar level, I feel like we all do feel quite a bit more confident that we would have fewer Black Wednesdays.
Yeah, I think the biggest thing was just like it. A lot of these things, not that we hadn't used AWS before or hadn't used a certain service, but it was just like seeing, well, using it in a more sort of real world situation. And this was our first time sort of using these in a sort of real world situation. So I think the next time we'll probably still panic, but just a bit less.
Amazing. Okay, massive well done. Thank you so much to both teams. You've done incredible. It's been so fun working with you, but we've still got our retro this afternoon, so I don't need to say goodbye yet. But yeah, thank you so much. Thank you everyone for coming, and I'm going to hand back over to Anna to close out for us.
Thank you.